Hi everyone, this is episode 13 of my engineering Oddcast, and today is the kickoff for my C++ improvement project. When I think about the characteristics of C++, I find that I think it has pretty good behavior when I'm trying to extend an object. I feel like it has pretty good behavior when I'm trying to aggregate multiple objects together. I feel like I'm wasting a lot of time when I need to restrict the behavior of an object or reduce the API that that a class has. Broadly speaking, that's the area I'm going to look at. But let me be a little bit more specific. So one of the things you'll find across any large company is that they will have invented new data types to represent things that in a smaller organization or one that hasn't yet encountered the problems would just use int or unsigned int for. So quantity or pricing in stock keeping is a pretty common one. And the reason that you create distinct types for those is because it's going to be relatively common for a function to take a quantity and a price and do something with those, and it's going to be potentially disastrous if you mix the two up. So you'll see occasionally headlines where someone on the stock market, instead of buying 1 million shares at $100 each, someone types in the wrong way round, and they end up buying far fewer shares than they wanted at a far higher price. And the same issue has affected retailers. It tends not to make such big headlines. I've seen it happen on some storefront where the price changes when you buy something because they've transposed quantity and price somewhere. So because C++ doesn't let us override functions based on like the name of the variable that's holding it or anything like that, we have to use types. What will be the solution in a lot of companies is to create a distinct type for each kind of counter. So at least you can't, in theory, mix up your quantities and your prices. And the same applies to a variety of other things that look kind of like integers. So customer ID will usually be wrapped in a custom type, and so on and so forth. Things like customer ID, C++ has relatively good support for, although I don't believe it was intentional that it should work like this. I'll show you how to do a customer ID type wrapper that works perfectly, because you don't need to do maths on customer IDs. It doesn't have any kind of semantics for that. It doesn't make sense to add two customer IDs together or take the average or multiply them. None of those operations on a thing that is an ID number make any sense. So because you don't want all of those, you just want a completely opaque data type that happens to hide some kind of integer, but you want it to be distinct from integers, you can use a enum class with the correct backing storage type, and that will do what you want. Where we get into more things being much more of a pain in the neck is when we're trying to define types for which it does make sense to do some mathematical operations on them. So it makes sense to be able to multiply a price by a quantity. It doesn't really make sense to multiply a quantity by a quantity or a price by a price. Those operations probably shouldn't be defined, but price times a quantity is a price, or it's a total price if your organization wants to start getting into that level of splitting things. And so what we end up with if we start defining these types, and bear in mind we're kind of forced to define these types because otherwise we're risking losing almost unbounded amounts of money from minor programming errors that we could have caught by doing this. So as we define these types, we end up defining all of these boilerplate function things that say I can increment or I can decrement a quantity, I can increment a quantity. So those would get used if, when you sell one thing, or you something gets returned to the warehouse, or order gets cancelled, so you restock it. Those operations invariably look like just, casting the wrapped type effectively to its underlying type, doing the operation, and then casting it on the way back out to the return type. But the problem is that we have to define those somehow. That means we have to write lines of code for them somehow. And that means when we're debugging the program or trying to understand what's actually happened, we have to read all those lines of code to be certain that the function was implemented correctly. And that's colossal pain in the neck. It comprises the bulk of some code bases is these functions, and I just want to get rid of them completely, if to the extent possible, or at least reduce the amount of code and the chance of it being incorrect to a level where we're all happy that we can just ignore it. And so we have various ways that could possibly happen in modern C++. So we have the option all the way back to C-style macros, the option of mix-in style classes. We could write it define it not in C++ and have something else generate C++ code for us. That obviously works, and it means that once you've debugged that process, it kind of works forever. But now you're maintaining another language. You're maintaining another compiler that runs before your main C++ compiler, and this is all to work around what I personally feel is just a minor deficiency in the language. We could define some annotations, so C++ attributes, to help the compiler check that what we've done is what we're saying we're doing. We could define attributes that tell the compiler to generate the missing code, or we could perhaps use some entirely new syntax, or modify some existing valid syntaxes in C++ to generate this, to instruct the compiler to generate this code for us. Now, that's a long continuum of things, and I've tried to present it in order of like most backwardly compatible all the way to C potentially at one end, and least changes to anything in the world of the C++ standard or compilers. So if we did this all using traditional C macros, we wouldn't need to change any of the standards, we wouldn't need to change any of the compilers, and potentially you could use it all the way back to 1960 whatever, when the first C compiler with a normal preprocessor existed. I don't think that's going to be possible, to be frank with you, but we'll have a look at it because due diligence demands that we should. And right the way through to, like, if we use attributes to mean something, if we're using attributes to say the compiler, here, this function is meant to be a pass-through to increment of an integer, but with the appropriate casts added, that doesn't actually require changes to the compilers. We might want to change the standard to say this attribute means this. The reason it doesn't require changes to the compiler is because if it doesn't do those checks, but the program was correct anyway, it will still have the right behavior, and it becomes then what we call in the industry a quality of implementation issue. So a more higher quality compiler might choose to take that information and then check the function, and they can use that as a sales pitch to get customers. But it's not required for anyone to actually do anything other than look at that attribute and ignore it to be compliant with the standard. the final two I mentioned, where either attributes or some other new syntax is used to make the compiler generate the missing functions, that obviously requires changes to the standard to make those, to define what's going to happen, and it requires changes to all the compilers if they're going to remain conforming, because a compiler that doesn't generate the missing code will not be able to compile the program. The reason I mentioned attributes as an option there is the rules on defining new attributes are sort of relatively well understood, and because it's attributes, it's like kind of the attribute syntax is inherently namespaced, which means if we pick a new name for the attribute that doesn't conflict with any current or anticipated future use of an attribute name, we're not burning very much in the way of future syntax, right? We're just burning that name, can't be used to mean anything else in the near future. If it turns out this thing that we're doing isn't a good idea and we want to cancel it later, we haven't burned a lot of, you haven't made a lot of potential future activities in the C++ standard invalid. Whereas, for example, if we want to invent a new keyword that's got compatibility issues, if we want to use an existing, extend the use of an existing keyword to also mean something else, it also means something related to this, where that's a much more significant restriction on the future evolution of the language, because as soon as we use some syntax to mean this, it can't mean that. So we should be very careful about how much of this non-renewable resource of syntax that's available to us we're burning up by defining that it means this, rather than leaving it undefined and allowing us to use it in the future. At the same time, we shouldn't be too scared of, we need to be appropriately conservatory of these resources, but they are there to be used for the C++ language. We've got to strike the balance of, if we're going to say we're going to use this, we have to be able to say, I think that it's as valuable a use of it as most of the existing things are. And let's say that that's a bar. What we're looking for is, in general, a way to improve the experience when you want to restrict the API of a certain type to behave in another way. And that includes making opaque types that are broadly the same as something else, or even have exactly the same storage as something existing, but that have different semantics. So restricted versions of integers, explicitly want to pull those in because they're int and so forth are basic types, not class types, and so it's important that those are able to be restricted by this mechanism. It's important also that we have a way to restrict class types. So some organizations will use a class type called decimal or big decimal or whatever to represent these quantity or value types, and that needs to work as well. In the spirit of not driving everyone mad, I would like the syntax to be the same whether you're restricting a basic type or a class type. So let's talk about how we're going to evaluate any possible solutions that we come up with. So it's obviously good if it works with existing compilers with no modifications, because that allows to fix the problem for more people. I think because this is a real problem that's been affecting people for many, many, many decades, that it's unlikely that a great solution that works with existing compiler technology is out there, because I think people have legitimately been looking for it. I think it would have been found. Does not mean we will not look for it ourselves, or myself, but I do not expect to find anything in that category, frankly. So assuming that we do need to modify, or we will need to modify the C++, the definition of what C++ is, I think criteria for evaluation that are important are how much future syntax space are we burning here? Is that defensively proportionate to what we're gaining? Is one side of it. Another thing that I feel personally is very important is if we show this syntax to someone who, let's say, is experienced up through C++ 17, if they look at code with this syntax, will they understand what it means? So I don't want to use the word intuitive because I don't think anything about programming computers, frankly, is intuitive to most people. But if you are a trained, experienced C++ engineer from a previous version and you look at what this says, does it make sense to you? Finally, I know it's important to the C++, to anything that goes into the C++ standard, as well as what I've already articulated, those are important factors as well, but it's important that it is computationally sensible to parse this syntax. It's computationally sensible to anything you demand about what is done with it has to be computationally sensible, which means ideally sublinear complexity. So we don't want to start demanding something that makes exponential demands on the compiler's resources, because systems do not have infinite memory and infinite computational capability. And we would ideally like it to be faster rather than slower if we're going to do anything. Personally, what I would like to see as well, and this is something that's outside the realm of the C++ standard, this is an implementation side of things, but I would like it to be the case that if you are using this syntax and the compiler supports it, well, if you're using whatever we come up with, that the debug version of your code is not massively bloated compared to the optimized version of your code, and the behavior of the debugger and so forth all makes sense as you're doing it. We don't want to create new burdens in other parts of the software development and maintenance lifecycle in the course of merely typing less into the IDE. If I achieved that it's near zero typing into the IDE, but the debugging experience was a disaster, I would not be satisfied with that. I would in fact say we shouldn't make that change, for sure. The task is to investigate what can be done, filter in or filter out things based on some of the more obvious criteria that I've mentioned, and then report on, versus the criteria we've talked about, how does a solution perform, and also does it have any interesting other effects. So potentially there's a way that might address another perceived problem in C++. That would be interesting to know if we encounter such a thing. I'm hesitant to emphasize that too much because everyone's perception of what could be improved is different. And so merely because I see a solution and think it could help with some other thing that I feel is a problem doesn't mean anyone else thinks that thing needs changing. But still, we will talk about it. It's also obviously going to be the case that I might stumble across a solution that I'm at most ambivalent about, but it could solve a problem that 99% of people think is real, and I will endeavour to think about that. But we run into the classic Rumsfeld conundrum of I don't know what I don't know, and I can't therefore necessarily answer that kind of question. In the next video on the C++ side of things. Probably actually what I'll do is I'll take you through real implementation of one of these pairs of quantity and price types, probably based straight onto integers. And I'll show you the amount of typing, why it's burdensome, and we'll look at what one can do with obvious macros and perhaps with mix-ins, and why those approaches are not going to actually solve this problem for everybody. Thank you for coming to my kickoff meeting, and I hope you find this series valuable. Cheerio.